When looking at factoring, what we have to remember is that when I look at an equation like this, to go from 2 times x plus 3, we've expanded out. So this is expanding. So factoring is actually just the opposite. So we're going the other way. So when we look at this, if I want to factor, what I want to do is I want to say, how can I take something out of both of these terms or all of these terms to turn it into a multiplication? So if I look at this, we've got 2 times x is 2x and 2 times 3 is 6. Well, going the other way, I know that I can divide both of those terms by 2, so I put the 2 out front and I factor it. This is the most common way of factoring, or the simplest way. It's called common factoring. So all we're doing is we're looking for a common value between all of the terms within our polynomial. So sometimes, as in this first one, I can see that both of these terms can divide by 3. So I'm going to put the 3 in front, and then I'm going to start a bracket. And then all I'm doing is I'm looking, if I divide this by 3, what am I left with? Well, 3a divided by 3 would be a. I put the sign in, and then what is this going to be if I divide by 3? That would be 3. So if I'm looking at that, 3a minus 9 would equal 3 times a minus 3. And if I want to check if I'm right, all I have to do is multiply that back out. 3 times a is 3a, 3 times negative 3 is negative 9. Sometimes it can also be a variable. So if I look at these terms, both of these terms have an x. Now what I'm looking for is the smallest exponent of x, because that means that's the least amount of x's. So I can't take more x's than that out. So I've got a 2 and a 1. So 1 is obviously smaller than 2. So I'm going to take 1x out. Now I'm going to start my bracket. X squared divided by x is going to give me x. 2x divided by divided by x is going to give me 2. I could have something that has both a variable and a coefficient. I'm going to deal with the coefficients first and then the variables. I've got 5 and 10. I know they can both divide by 5. I've got a squared and a, which is to the power of 1. So I know I can only take out 1a. So now when I go through this, 5a squared, divided by 5a. Well, 5 divided by 5 is 1, so I don't need to put anything there. A squared divided by a is going to give me 1a. Let's put our equal signs here. Next, we're looking at 10a divided by 5a. Well, 10 divided by 5 is 2. A divided by a is 1, so I'm just going to leave that. Again, if I were to multiply this back out, I know that I've got the right answer, because 5a times a is 5a squared, and 5a times 2 is 10a. Let's look at another example. Well, this one looks a little bit harder because it's got 3 terms, there's more going on, but I'm just going to do it the same way. I'm going to look at all of the coefficients first. I've got 2, 6, and 12. Well, those are all even numbers, so I can divide them by 2. Now I've got x to the 3, x to the 2, and x to the 1. Well, 1 is smaller than 2 and 3, so that's what I'm going to put here. Now I'm going to see what I have left. Well, 2x, I know that the 2 is taken care of. And another way of thinking of this is, how many x's do I need to get back to 3? Well, I've got 1x here, so I'm going to need 2 more x's to get back to 3. Now let's put the sign that we have, that's that middle sign. 2 times what gives me 6? Well, 2 times 3 gives me 6. I've got 1x already, I need 1 more x to get to x squared. Put the sign in. 2 times what gives me 12? That's 6, and I've already got my x, so I'm going to close the brackets. You know you're right if you can multiply it back out and you get the line before. The answer is on the page here if you're checking your answer. You're just working backwards. Looking at this one, it's a little bit harder, but 10 and 15 both divide by 5. And then what we're going to look at is our x's. This time we've got an x squared and an x cubed. Well, squared is smaller than cubed, so that's what I'm going to work with. We've got x squared. 5 times 2 gives me 10. I've got 2 x's here, so I need 1 more x. So I'm going to put that in. And then put the sign in. We've got minus 3, and I just close the bracket because I have x squared already, and I needed to get to x squared, so I'm all done. Kind of the last one, where now we have multiple different variables. All we're going to do is the same thing as what we did before. We're going to look at the coefficients, and in the first one, we'll look at our x's, then we'll look at our y's. In the second one, coefficients, a's, b's, c's. Just do it in steps. So for f, I know they both terms can divide by 3, so I'm going to put the 3 out front. I'm going to look at my x's. I've got a 1 and a 2. I know that 1 is smaller than 2, so I'm just going to have x to the 1, or just x. Look at my y's. All of the terms have y, but 1 is the tallest one, or sorry, highest one, so I'm going to put that. So now I'm going to just look at this. 3 times what gives me 3? Well, it's just 1. I need 1 more x, and I need no more y's, so I'm just going to leave it like that. Plus 4. 3 times 4 is 12. I've got an x, I've got a y, so I'm all done. Last one of this kind. We've got 15 and 20. Well, they both divide by 3. A to the 3 and a to the 2. 2 is smaller than 3, so I'm going to use a to the 2. B to the 4, b to the 5. 4 is smaller than 5, so I'm going to use that. And then c essentially to the 1, or c to the 3, so I'm going to use just c. Now I'm going to start my bracket. 3 times 5 gives me 15, so I'm going to put my 3 in. I've got 2 a's here. I need to have 3 a's in total, so I'm going to put in a. I've got 4 b's, so I'm all done with my b's because there was 4 here. I've got 1 c, and I've got 1 c, so I'm all done with that. So I'm going to now put my plus, and then 5 times 4 gives me 20. I've got my 2 a's here. I only needed 2 a's, so I'm done with my a's. I've got 4 b's, so I need 1 more b. And I've got 1 c, so I need 2 more c's. Again, if you multiply it all back, you would get back to your first line. This one's a little bit harder. So factors can sometimes be an entire polynomial. So if I'm looking at this, what I'm looking at is this whole value here is common in both of these terms. So what I'm going to do is I'm kind of thinking of it like this. I'll rewrite this question kind of down here. I'll write ay plus by. Well, if I did a common factor there, it would be y, and then we'd get a plus b. Well, what if I told you later that y was equal to 2x plus 1? Well, then all we would do is we'd rewrite 2x plus 1 and then a plus b. It hasn't changed anything, and if you need to look at a question and change it to something like this, you absolutely can do it. But if you can recognize that those two brackets are common, well, let's put the bracket in front and let's look at it that way. I've got 2x plus 1, and in the first term, I just need an a. Plus, I've got 2x plus 1, and then in the second term, I need a b, just like we wrote below. In this second one, I look at the question, I see that I've got a common bracket here and here. So I'm going to put the common bracket in front. And then whatever's outside the brackets, what's going to go in my second bracket. So 2, put the sign, minus 3c. Close the bracket. ab times 2 will give me 2 times a plus b minus 3c times a plus b. And so now I know I'm correct. I've expanded that out just to show you that I was right in this case. Final type of common factoring is factor by grouping. So if you're given 4 or more polynomials, sometimes this is a good way to solve the question or simplify it down. So if I look at this, when you're solving by grouping, sometimes you want to rearrange it to make it look a little nicer. But here, I'm going to factor these two, and then I'm going to factor these two, and hopefully I'm going to get a question that looks kind of like this, so I can simplify it nice. So in the first two values, I see that I can take out an x. So if I take out an x, I'm going to be left with b plus 3. In the second two values, I see that I can take out a y. So I'm going to do the same thing, and I'm going to be left with b plus 3 again. Now that's my common factor. So then this is going to be b plus 3 times x plus y. And now we've simplified it. Let's look at the next one. If I wanted to rearrange this, I definitely could. So if you looked at this and you didn't see that the first term I could divide by 3, and then the second term I could divide by something else, if you want to work it out that way, you definitely can. You can rearrange it. You could do it just as it's written. Let's say you wanted to rearrange it. I know some people like to have a positive and a negative. So if I rearranged this to something like this, and then minus 20, I definitely could. So if I took the first one, I would have 3m, and then that's going to be 3 minus 5m. Okay, I looked here, I saw that this and this both divide by 3. I looked at my m's, I've got a 1 and a 2, so I took out 3m. I'm left with that bracket. Plus, let's look at what we've got here. Well, both of these terms divide by 4. So now I've got 4 times 3 gives me 12 minus 5m. Well, there and there, common factor. So now we're going to be left with 3 minus 5m times 3m plus 4. And if I went through and multiplied that all out, I would get back to my first line. You can also see that you can actually common factor these, which would make things a little bit easier. Or sorry, collect like terms, and that would help us in the long run to do something a little bit different that you'll learn later on.